Oh, good evening, good evening. Good evening, ladies and gentlemen. Welcome to WeatherBrains, episode number 967. 967. This is for Monday, the 29th of July. Yes, it is. Little secret here. We're actually recording this on Thursday, July 25th, because as this is airing on the television side and dropping on the podcast side, I'm actually in Chicago, taking a little week off here. Be at Chicago on Monday to see a White Sox game. Not exactly the best team in Major League Baseball. In fact, you might argue they're the worst team, but looking forward to being there. We're trying to go to all the Major League ballparks for those that have been watching me for a while. And then tomorrow night, Tuesday night, the 30th, I will be in Milwaukee. Hey, the Brewers and the Braves. So we'll cross off Guaranteed Rate Field and also Milwaukee, and then we'll be back by the middle of next week. But we'll be back on the regular Monday schedule on August the 5th. And we'll be on Monday nights all the way through Christmas. This is the second week off of the year. Get 3 a year. So welcome. Hey, this is the pre-show. This is the magical, marvelous time of the program where we do three things. We share boring personal stories, humorous anecdotes, and from time to time, we say outrageous things. So we'll see if we can come up with something really outrageous tonight. So again, it's a Thursday night special. If you're watching live, we're glad you're here. And if you're watching on the television side, glad you're here. And hopefully the weather's not that active. And for those that don't know, if you're new to WeatherBrains, we have the video version, which is on YouTube and which you're watching. This will not be in the audio podcast. Then we have the audio version. And most people listen, about 3 and 4 people that consume this show, they listen to the audio podcast. 1 in 4 watch. They watch it either live or they watch it later. And the only way to get the pre-show, it's by watching the YouTube version, whether you're live or watching it later. But tonight we're on the television side because the TV folks are picking it up early tonight. So welcome to our television viewers. And again, we're typically live Monday nights at 7 o'clock Central, 8 o'clock Eastern. Had a really good show the last year. In case you missed the last episode, we had some of the folks from the Weather Service in NOAA that they were the research folks for the movie Twisters. Of course, our own Rick Smith was in the movie Twisters. Little cameo there. So if you want to know more about the movie and the making of the movie, go check out 966. That was the show for July 22nd. And we should have a little fun tonight. But again, the weather's been pretty calm. We've got this lull in the tropics. We had Beryl that came out of the gate just breathing fire. And then it just went dead. And that happens from time to time. And again, we have reason to believe that the SAL, the Saharan air layer out there, will kind of subside by mid-August, and things could get pretty active mid-August through mid-October. So don't be lulled to sleep. But again, I'll be honest with you. I look at my schedule every year. And again, in summer, I'll take 2 weeks. I'll take typically the third week in June. That's easy. That week typically is the quietest week of the year. Odds of a problem are low. But I looked at the second one, which is typically the end of July or the 1st of August. And with the expected active hurricane season, I'm thinking, oh boy, I could just see a monstrous hurricane in the Gulf of Mexico coming right up toward Mobile Bay. And I've had many a vacation week called off because of weather, which is nothing new, and that's fine if it happens. It is what it is. But I'm thankful that did not happen this year. And the third week I take is at Christmas. And where we are down here in the Deep South, some very strange things can happen at Christmas time. Anything from tornadoes to flooding to winter storms, ice storms, you name it, we could have it. So we're 3.5 minutes away from the start of the show, and I'm the only person here. Do you think I could hold a show by myself for 2 hours? Yeah, I could do that. If you watch me yak away on the green wall during severe weather, if we're talking about weather, I can talk forever. That's the one thing about these the old school television newscasts we do. The producers, they know that if they need somebody to fill time, just go to the weather guy, weather lady, whoever's in the room. They can fill the time, even if there's nothing going on. We can talk, and that happens a lot. Like a live shot's dropped or some package didn't make it on time. You need to fill 2 minutes. 2 minutes, that's no problem. I can fill 2 hours. But I do believe that most folks, I know that Rick Smith could not make it tonight, and I know we'll have some others that can't because this is vacation season. But I think that James Adelot, who is out in Tulsa, he was scheduled to lead the discussion tonight. So hopefully somebody will be here. But if not, I've always got some stuff to talk about. Good to say. I know that Kim is involved in this. Kim of our show here, Dr. Cloco McLean, in some research, just posted on my Facebook page a couple of National Weather Service maps prior to severe weather events. Had one that was posted from December 9th, 2023, and then one that was posted from March 24th, 2021. And they're doing some research in terms of people not understanding those graphics and the maps, the local weather service here. And what I'm asking people to do on the social media post is to comment if you're interested in taking part in a short interview about your experience with social media severe weather updates. Because what happens, we will post a map, and it seems to be a fairly simple, easy to understand map. And then the first 25, 30 comments will be, what about my hometown? And they honestly cannot understand the map. And we know that we have an issue with geography literacy in this country, but I think it goes beyond that. And the easiest thing to do if you're in the weather business is to be condescending and criticize your users and the people that follow you. But no, that's not what we're here to do. That's ridiculous. We have to adjust our products and services for them. And I'm hoping that research that they're conducting will help us all to make better graphics that we post not only on old school television, but across the social platforms and everything else. So, all right, the gang is piling in here at the top of the hour. A Thursday night special. I like it. Let's see here. Jen, where are you tonight? Are you home?
I'm in my kitchen.
I like it.
My lighting is so stinky in that office, and I was playing with it Monday night. I'm like, you know what? I'm just going to move where I have all this better light. So I'm in my kitchen right now. Plus, I'm closer to the wine. Sorry, James ate a lot. You probably totally miss me right now.
Closer to the refrigerator.
We have
Yeah, there we go.
We have to ask what's for dinner. I mean, what you got cooking?
I had chicken and macaroni and cheese and tomatoes, little great tomatoes that I've been growing out back.
Yeah. I had chili here, and I'll probably pay for it in about an hour and a half. So.
Oh boy!
Oh
boy!
Oh dear!
We're not going to go down that. There's a lot of things we could say
No.
here. We're going to not go.
Never
down
goes
that path.
dead. You'll know what the deal is.
Yeah. So and I don't eat dinner. I don't know about James ate a lot. We're doing the TV thing, so it's 6:30. I typically eat at the end of the 10 o'clock news, which is about 11 o'clock at night. And today for lunch, I had spaghetti, macaroni and cheese, and green beans from the Piggly Wiggly Deli, which was really good.
Can I ask you one question? What time do you get to bed?
Yeah.
Well, I sleep from 1. Most people know this. I sleep from 1 until 4 a.m., 3 hours a night, which is not especially healthy. And I do better on the weekend. I do. I do better on the weekend, but during the week, it's 1 to 4. And what's weird, I can't wait to wake up at 4 o'clock and do what I do. I'm living a dream here. I mean, I get to do what I love to do, and I've been doing this for so long, and I just still can't wait. It's fascinating to me. They're paying me to tell a weather story, and so I feel energized. And as long as I'm energized, let's go. Let's keep going.
Well, I tell you that's
right,
unhealthy as I sit here and eat almond M&Ms. So.
Oh.
Hey, Sam, can you hear us okay? Yo, Sam. Can you hear us okay?
No, we can't hear him.
I do not see his
Cannot
mute
hear you.
icon on, though.
No, that's
Mm-mm.
a strange thing.
No. I think he can hear us. We cannot hear him.
It's Norman, so Cameron Nixon probably broke into his place and tore up his microphone.
God, yeah.
Wow.
Is this any better?
Yeah.
Yeah.
Oh yeah,
Yay!
loud and clear. Loud and clear.
Awesome.
All right, good. Let's get this sucker rolling here. All right, track 1 is recording. Track 2 is recording. Here we go in 5, 4, 3, 2, 1.
You're listening to WeatherBrains. They're kind of a big deal.
Well, just maybe not. Whatever. This is WeatherBrains, episode number 967. And this show is for the 29th of July, 2024. But a little secret here just between us. We're actually recording the show on Thursday, the 25th. We're doing it live as a Thursday night special. And that I've got a little vacation week next week. But we'll be on Monday nights after this all the way through Christmas, my second vacation week of the summer. But hey, we love Thursday night specials. They're good. They're fun. I see Troy Kimmel is down in
Birmingham,
Austin.
Alabama next week. I wonder. what could happen in Birmingham, Alabama next week?
Yeah. And I said in the pre-show, but before this, I had fear looking at that week off at the end of July, the 1st of August, that a Category 5 would be coming up Mobile Bay that week.
You meant Category
we have been
6, right? Category 6.
Right. Well, I saw that on TikTok. Yeah, the Category 6 coming up Mobile Bay.
Mm-hmm.
But we are very fortunate. But no, I do. We're trying to go to all the Major League Baseball parks. And longtime listeners know that. And this summer, we're going to cross off 2 next week. We're going to go to Guaranteed Rate Field. Has anybody ever heard the song Bad Bad Leroy Brown?
Oh, yeah.
Of course.
Where was Bad Bad Leroy Brown from? The south side of Chicago.
Chicago, yeah.
Which is where we will be for that White Sox game. And then from there, we're going to take the train up to Milwaukee and catch a Brewers game. So we're going to knock off Chicago, the White Sox, and the Brewers on our little baseball tour next week. But what's happening down in Austin, Troy? How's your heat down there?
You know, today we had looked like it was going to start raining about midday, and then everything just decided, oh, there's Troy over there. Let's shut everything down. And it did. It completely shut down. I don't know what it is, but we're still underneath this weakness in the atmosphere that's been hanging around the last week or so. And got, since we've last talked on Monday evening, had a couple of inches of rain, but and the lakes are up, which are really nice. And seems that we have erased a lot of the drought. The drought update came in this morning. And so that's good news.
Yeah, and we're on the east side of that weakness in the ridge, and we're kind of in this conveyor belt, and we have had just multiple rounds of very beneficial rain.
Yeah,
I look out almost every afternoon at 3:00. It's like 77 degrees. That's a win. That's a win at this latitude.
Yep.
And the reservoirs are full. A lot of rain, so it's a good thing. So let's go up north to Jen in the Arctic Circle. Jen, what was your high today?
Like we got up to about 80 today. So that wasn't too bad. We had a front come through yesterday. I know James A is making faces at me and give me a thumbs down, but I'm loving it. We had some pretty good rain yesterday with that front. And now we're dry. We're going to warm up again this weekend. Then we're hot again. And we've got more rain early next week. So the pattern changes. But yeah, I was just sitting outside before we hopped on the show and just sat out there for a minute. It just felt good. The birds were flying around. I've got a garden out back. I had some of my tomatoes with my dinner. And so all is well here in the Ohio Valley.
Yeah. And again, I look at some of the footage coming out of Alberta, Canada. Those forest fires are horrible up in the national forest up there. I think the community is Jasper. But whatever, they've been having a really rough ride. So we are so thankful and blessed to have clouds and rain and coolness here. But James Adelot in Tulsa, let's bring in our guest. We're going to have a fun show tonight. I can't wait.
Let's do it. We are continuing our Norman PhD tour, it looks like, with Dr. Sam Lillo. He is a senior software engineer at DTN, which is, you know what? I don't even know what that is. Tell me what DTN is. Tell me what you do. What does a senior software engineer at DTN actually do every day?
Or can you hear me now?
Yeah, loud and clear.
All right. All right. Perfect. Great. Well, thanks for having me. Yeah, I don't know if I can compete with Sean Wall. That's a tough act to follow, but I'll do my best. But yeah, no, I joined DTN a little over 2 years ago now, and I work on their forecast team. So forecast team is working on our forecast engine that we provide, all the data, the forecast data for them to provide to their clients, whether it be, road weather, agriculture, energy, all across the board. DTN's been around for a long time, and it's been evolving. We've been growing a lot over the last several years, and I don't know, I'm excited to be joining the team at this point in its life. I think we have a lot of exciting stuff ahead.
How in the world did you, what made you want to do the PhD in meteorology? Most people that start meteorology as an undergrad, they're done before they finish undergrad. And so you survived undergrad, master's, PhD. That is no small feat. Tell us about your education.
That's fair. I think so. I did my master's at OU, and I actually went into industry for about a year or so, and came back from a PhD. And I felt like there was some unfinished work that I wanted to dive deeper into some of my master's research, and I was lucky enough to have a really great advisor, David Parsons, and we kind of just spent a number of years together doing deep dives into air growth and numerical weather prediction, and it was a lot of fun. And it was almost difficult to leave the PhD. They had to kick me out, basically.
Now that you've just gone too far saying that, because
okay.
What I mean, you get more and more specialized as you go further through education. At least most people do. What kind of surprised you about your PhD journey that you thought you were not interested in at all, and that you did find some interest in after all?
That's a great question. I think I really appreciate my grad school experience in general for opening up the world of programming. I think I had already had like a little bit of experience in undergrad, but I really didn't. I don't know. I didn't get too much until I got into grad school, and obviously that's what's still applicable today, whether you're in industry and academia. Across the board, programming is the primary skill to take you where you want to go. And so I was really appreciative of those extra years, I think, in academia to kind of grow my experience, particularly with Python. Is a very popular coding language. And I think that was maybe unexpected. I think one of the things, I had this conversation with a lot of my friends going through the same PhD experience, was that it wasn't so much the project you were working on or the research you were doing. It was a lot about the skill sets you were gaining along the way. And I think my advice to anybody actually going through the PhD process is to don't forget about that, because like you said, you get more and more specialized as you go through the PhD, which is great. You get to do this wicked deep dive into one specific subject, but you don't want to forget those broader skill sets that you're developing, because that's what's really going to matter at the end of the day.
Walk us through what you did for a dissertation project, because just reading it kind of blows my. Better do the James level, the Okie James level. So that's third, maybe fourth grade. Field challenge.
Kick it down a notch for all of us.
Keep it going down. Head it down, please.
No problem at all. No, I really enjoyed talking about it, to be honest, too, at all levels. So there was a study out from the ECMWF, I think it might have been 2011, that was looking at air growth in their model that originated over the central United States and impacted the quality of forecasts over Europe 6 days later. And they were connecting the quality of those forecasts to convective activity over the central United States, and specifically connecting bad forecast busts over Europe. And so my master's was kind of doing a little bit of a deeper dive into that, into the pattern evolution and how that air growth kind of infiltrated the pattern, infiltrated the jet stream across the Atlantic into Europe. And my PhD, yeah, just did a little bit of a deeper dive, started looking at forecast bus situations around the world, as well as how it impacts forecasts going out even farther, 2 to 3 weeks in advance, and just a little bit deeper into the dynamics thereof. I love the across scale interaction stuff there. It's just, I don't know, I think that's so interesting. All levels. I think, it's funny. I went to OU. I did not have a convective background at all. I was very fortunate to be surrounded by some brilliant convective scientists my entire time there. I was not one of them. I love the large scale stuff. I love the subseasonal forecasting, seasonal stuff. But so I appreciated having a project that kind of connected the two, that brought the two together.
You're leading me to the next question, subseasonal and seasonal forecasting.
Sure,
are we better? Are we about the same as we were 10 years ago? What's driven the improvement, if any? And what value should, I guess, various people use that forecast for? Obviously, farmers come immediately to mind, but walk us through that.
You're right. Definitely agriculture, energy, insurance, all these sectors really benefit from the subseasonal and seasonal forecasts. Yeah, it's interesting because a lot of techniques for subseasonal and seasonal forecasting are maybe the same as they were 10 years ago. Maybe it's evolved a little bit. We're still looking at teleconnections. We're still looking at the NAO, the PNA, all your favorite 3-letter acronyms. And so in a lot of ways, those things haven't changed. AI is definitely playing a huge role. The last 5 years, the surge in the use of machine learning in weather prediction definitely extends to the longer range forecast. And I think definitely the longer range forecast, because that's where the dynamic models, right at a certain point, errors are saturating the forecast, and there's a horizon. There's about 2 to 3 weeks, 3 weeks, I think, at the very max, that we can have any sort of skill in fully physical dynamical models. And so this is where we really need to employ statistics and AI-driven models to get some better skill in the subseasonal and seasonal ranges. I do think we're getting there. It's a slow and steady progression. And I think that's kind of what's exciting about it. Anybody who has interest in this space can jump in, and there's tons of literature out there. There's tons of stuff to catch up on for sure. But you're not going to be left behind. There's so much to be done. There's so much work left to be done in the long range space, and I think that's what always excited me about it. Is this gray zone between we're doing pretty well for 7 to 10 days, and we're doing pretty well actually in climate, but that 2 month to 2 year range is tough.
Sam,
let me get to Troy because he's got a great question.
Yeah, just one, because I want to get kind of your opinion on AI, because in ways it still scares the Jesus out of me sometimes. But my question for you in your advanced level work you're doing, you're already seeing some changes that I assume are the result of AI to some degree, right?
Oh yeah, definitely. And this extends across all areas of meteorology. It's kind of incredible. Obviously, the stuff that's been making a big splash in the last 6-9 months, I guess, is actually fully dynamical models like ForecastNet and GraphCast that are displaying potentially, the same level of skill as these MWF. And that's amazing. I think we're just getting to the tip of the iceberg in terms of what we can do with that, though. I don't know, what I'm really excited about is ensemble applications. What is great about these types of models is that once they're trained, you can run them, on a laptop, you can run them in a split second. So I'm really excited about the potential for developing, these huge sample size ensembles and really fill out that probabilistic space, which, that is something obviously communicating probability and confidence, that's always been a challenge. and it still is. And the better we can do with ensembles, the better that, I don't know, the better that we'll get at that challenge for sure.
Do you see in the future where AI begins to replace the forecaster? Or are the humans
not for a while?
Okay.
Forecasters will always play some role in one way or another. Even at the very end of the day, if we have absolutely perfect forecast models, which I don't see happening, for a long time at the very least. Yeah. Even if we have the most perfect forecast models, we still need communication. I think the role of the forecaster is going to be moving a little bit more into the communication arena for sure. And I think really it's going to be a matter of forecasters will need to just learn how to harness these AI tools better and better. But I think we'll have humans around for a while.
Thank you.
Let me ask a long range forecasting question.
Sure.
And I need to word it carefully or Troy will jump off sides.
Sam, run.
There are a subset of meteorologists who will claim, hey, this tropical storm was predicted last fall by...
Okay.
Yeah.
So is there any skill at all in that? And if so, what is it?
I think there's like a very specific provider that you might be referring to, a very specific source. There's certainly patterns, there's certainly pattern recognition and recurring patterns. And I think there's value in discussing that. And we shouldn't dismiss some of that science to be able to claim, a specific individual event that's, at a specific location, specific time. No, that's not the thing. It's just not. I think this is where we get into probabilistic space. You can talk about increased probability of a tropical cyclone or tropical activity in general, and this is useful information. It's unfortunate because these claims about being able to predict a hurricane months out, they unfortunately overshadow what's actually useful and what's actually possible, which is to say, hey, this week there is an increased chance of tropical cyclone activity in this general area, in the Gulf or something. And that's valuable, But yeah, unfortunately, the crazy claims can overshadow that value.
Hey, James A., can I hop in here real quick?
Absolutely.
I want to ask really quickly about verification for existing seasonal outlooks. They're hyped up. This Thursday, NOAA will be presenting their winter weather outlook. This Friday, next Thursday, NOAA will be presenting their summer outlook. What's the verification on these? Do we have any idea?
Fortunately for CPC, at least, for their weeks 3-4 forecast, there is an archive that's available publicly where they have a graph of a couple of different skill scores. And so we can actually visualize that. We can see that performance. As far as their seasonal forecast go, I'm actually not sure about a source. I'm fairly sure we can grab the data, and verify for ourselves. I completely agree with you, though. We need transparency, whether it's in NOAA, whether it's in the private sector and industry. The only way that we get anywhere with the science is through transparency of performance. This is actually something that really kills me about seasonal tornado outlooks or even the weekly tornado outlooks, because I don't know, people draw, a circle around Oklahoma and Kansas in mid-May and say, like, tornadoes. Cool. Yeah, you're not demonstrating skill necessarily.
Do you think so?
Yeah, right, exactly. Yeah. And so I think, there really needs to be better objective performance statistics across the board.
Yeah, and
that being said, NOAA does a good job. Oh, go ahead.
I think that would help because it's just, sometimes they're not good. There's a limited skill set, and I do think we have to be transparent. There's a lot of things in the science we can do well, and there's a lot of things that we can't do, and we might do well in 5 years and 10 years as we get all these tools. But I'm all for seasonal outlooks, but I think we have to be realistic with the users and explain the limitations here. And that goes with the hurricane outlooks. And that, goodness, the national media, you'd think the national NOAA hurricane outlook for the season is coming out on May 21st. Stop the presses. All things stop. It's
Sure.
not the end all. And what do the end users do with this? What if they're right?
Yeah.
What if it's a
Right.
limited season and you got one hurricane and it comes up on your city and it destroys your neighborhood? What good is that? So I just,
So I couldn't agree more.
I-
With this,
Yeah.
with hurricane outlooks, it's really tough because everyone, the contents of a hurricane outlook, a seasonal hurricane outlook, is a range of number of named storms, hurricanes, major hurricanes, maybe accumulated cyclone energy, but these are aggregate numbers across an entire season and across an entire ocean basin. It doesn't really actually give a user that much helpful information, in my opinion at least, because we're not talking about landfall, potential. We're not talking about, when or where a hurricane could strike. And just like you said, we could have one hurricane. If it hits a populated city, if it hits your house, it doesn't even matter. You could be in the middle of nowhere. It hits your house. That's what matters to you. And so, yeah, we definitely need to investigate what value there is in seasonal hurricane outlooks. I will say this. I think the main value actually of these press releases is just to promote awareness. Is just, okay, put out your forecast in, the end of May, beginning of hurricane season, say whatever numbers you want. Really, it's just raising awareness that hurricane season is here. It's coming, and be prepared.
Yep, absolutely. And Jen, finally, we're circling around to you. We'll jump out of long-term forecasting briefly. Jen, what you got?
Yeah, Sam, it's nice to meet you. And
Too.
I, as most meteorologists and non-meteorologists, know DTN from RadarScope.
Yes.
Game changer, and being able to see what's happening, seeing storm motion, and just it's been an amazing product. Give me your thoughts on RadarScope, and then what are some of the other products that DTN offer?
Oh, I love RadarScope. I honestly, I think I didn't fully process that DTN owned it. When I joined, to be honest, I forgot, and then somebody mentioned about membership perks or something like that. I was like, oh wow, that's amazing. I completely forgot that we owned it, and now I'm so proud to be working for the company that has RadarScope, because it is just such an incredible product. Yeah, I don't know. I show it to my non-weather friends all the time. I'm like, listen, $10, just you get it. It's the best app you'll ever pay for. And this isn't, I'm not getting royalties or anything. It's a great app.
Do you know Mike Wolfenbarger, the guy that wrote the code for the app? Do you know Mike?
Mike.
I honestly don't know. I mean, it goes a ways back, I think, right?
Yeah. Yep.
Oh yeah, it goes a long way back.
Yeah.
But as far as I know, he still is the primary code developer for RadarScope, and he has always been accessible and listens to the end user, and he's just a great guy. So I hope y'all are taking good care of him.
I think I sat in on maybe one or two meetings that overlapped with some RadarScope engineers, and we're talking about our precipitation type detection, improving on that, and also how we integrate our forecast engine with the observations. And so we have this big Nowcast initiative that we're also working on at the moment. And I'll be honest, I think I messaged a friend of mine, like, I'm on a RadarScope meeting right now. And I was so excited to even just be, rubbing shoulders with these people, rubbing elbows with these people.
Sam, you've done some really cool stuff. Bill had left me a couple of notes. You did a paper on the polar vortex. Speaking of terms that get overused by the media, hey, there's a new word. Let's use it. What did you find out about? Summarize those findings and how they relate to extreme weather events, and also the Troy's favorite cold snap in February 2021.
Oh boy, yeah, that was a good one.
But I think, Sam, I mean, hopefully, what you're going to tell us is, this is the way I understand it, is the polar vortex has always been there. It's just something the media came along and sniffed out one day and said, that sounds cool. So I'm like James in Tulsa. I'm interested in knowing what you've learned, and please don't repeat that one from February of 21. Thank you.
Oh yeah, gosh, no, that was brutal. Yeah, so it can get complicated from a communication standpoint. There's really, I guess I would say, three different polar vortex type terms. The polar vortex itself, I think, scientifically best relates to actually the vortex in the stratosphere that sits over the Arctic and Antarctic, and that, we talk about sudden stratospheric warmings that can disturb the polar vortex, and this really gets into, again, subseasonal and seasonal forecasting. When you get that disturbance of the polar vortex, this is where you can end up with the North Atlantic Oscillation plummeting negative, and all this cold air then pouring down from Canada. And so a lot of people know the NAO and AO as correlating to significant weather events in the mid latitudes. So that's the polar vortex. There is the polar jet and the Arctic jet that it's in the troposphere. And so some people sometimes refer to the polar vortex as, I think, really the Arctic jet up in the higher latitudes in the troposphere. And then finally, there's tropospheric polar vortices, or TPVs. And so that's what I'm talking about in my paper. These are kind of these vortices off of the Arctic jet, and they are actually mesoscale in size. They're a little bit smaller in size. Really, what you would at best equated to the size of a hurricane, honestly. And this particular Arctic outbreak in February 2021 was, and a lot of Arctic outbreaks are related to these TPVs transported down from the Arctic into the mid-latitudes. And this one in particular was quite strong. This is also where you'll see these soundings where like the tropopause is, down, 5 feet above your head or something like that. And right. You'll see tweets or something from somebody talking about, smelling the ozone. Basically, the stratosphere is hanging down over your head because the TPV is moved so far south and is bringing, the stratosphere down with it. Anyway, so it takes with it this pool of very, very cold Arctic air. And that's what I was studying, is kind of, all right, is there a correlation? Is there a relationship between the strength and the depth of that TPV and the strength of the Arctic outbreak? And we found, yes, there is. And so it's really just a matter of looking at these features that offer a little bit of predictability, a little bit of added predictability in the week 1 to 2 range, that are sitting, 60, 70 degrees latitude, and looking for a mechanism that can transport them south. And that's when you can expect extreme weather, and probably it's going to be cold somewhere.
Is there any way that an operational forecaster like, I don't know, somebody at a TV station in Birmingham or Tulsa can look at a week or two in advance and say that?
Sorry, can look at what in advance?
What should we be looking at to give us that kind of information that we can have a little bit of confidence in saying that?
So I think the best forecast maps and the best products to look at would be, the 300 millibar winds. Really, they're reflected even at 500 millibar heights, because these TPVs, they have impact so far down in the troposphere. So you can look at 500 millibar heights, and you can see these closed contours, and honestly something that looks not too dissimilar from a hurricane, except that the vorticity isn't as concentrated in the center. Something that is closed off, and you can see if they're rotating around the Arctic, right? If there is a big ridge or something that's building over the Eastern Pacific, and the jet stream is surging north over Alaska, that's a mechanism. That's one way that it can kind of pick up one of those vortices over the Arctic and pull it down south. And that's what really to look for, is when you have those already amplified patterns, I guess, if there's something to amplify the jet stream, the waviness of the jet, and then on top of that, inject a TPV into the mix, then you have yourself, again, an extreme weather situation. I will say that the best. Sorry, I didn't. All right, so I like 5 millibar heights, but the one true way of looking at it is on tropopause maps, and so that's the this gets into potential vorticity and looking at the 2PV surface and potential temperature on there. But that's a little bit harder to maybe talk about the visualization, I suppose.
How often does an event like February, sorry, Troy, close your ears. How often does an event like February 2021 actually happen?
Good question. Yeah.
That one was pretty rare. I haven't looked at these outbreaks in a while. Yeah, that one was definitely a rare one. And I'm trying to remember if it was that one or I don't know, there were a couple that were not captured very well in the seasonal forecast or the monthly forecast. I think it might have been 2021. This is, again, nothing against like the Climate Prediction Center or any forecaster or provider, but like, yeah, I think they had, extensive warmth across the South, for example, and that busted pretty badly. Just one case, but again, these are cases that you want to look into after the fact. And it's difficult when you have such a rare event, when you have such an extreme event. That one was, it broke records. There was another one, February or late January 2019 is the one I'm thinking about actually too. Late January 2019. And that one also, right, we're talking about a return period that's pretty large. It's something that you wouldn't expect for even decades for some areas. So yeah, Troy, don't worry. Yeah.
I was going to say, Sam, if you said one's coming up this winter, I was going to come find you. Okay, just let you know.
That's fair.
Coming to find you.
Yeah, Troy, he's
see what La Nina.
Yeah,
we'll see what La Nina brings for us.
No, it's nothing like being in this office when the roof is falling in on it. So,
oh, geez.
Yeah.
Troy, it's an important note that Sam is a little further north than you are, so maybe
I can be on an airplane in 30 minutes. So,
I'm right now. I'm just outside of Boulder, Colorado. Actually, and I don't know. It's definitely different weather. I will say this. I loved forecasting when I was in Oklahoma. I had a great time. Doing my own forecasting for myself and all. I have no idea what's going on out here. It's crazy. Hats off to the National Weather Service forecasters here.
Well, how long you been up? How long you been up in Boulder, Sam?
Going on a little over 4 years now, I guess.
Okay. Well, there was that event a couple of years ago. Do y'all remember this? I'm pulling it off well, you know where I'm pulling it from. But Sam, you remember that Arctic blast? I remember the one that came through Cheyenne and then came down to Denver, and where we lost 50 degrees in 30. I mean,
I know that one.
You remember that one? That was amazing to watch that.
Yeah.
Just watch the surface maps on that one in southeast Wyoming and in eastern Colorado.
Oh yeah.
Yeah.
No, I mean, your weather stations couldn't keep up with it pretty much at that point. That was incredible. That was 2 winters ago, right? It wasn't last winter. It was the winter before that. What I loved about that one was that the weather app. So like, for example, the app on your iPhone, it couldn't keep up with it. And so like, it has a nowcasting part to it also, right? And I'm looking at the hourly forecast, and our temperature is already 20 degrees colder than the forecast 3 hours from now. And so like, it couldn't keep up with this cold front even close.
Well, that was in that case, guys. It seemed like the WFO up in Cheyenne set a record for a 1 hour temperature drop. I'm serious. I do remember something. I think Cheyenne, they did that in 1 hour. So
I think there were some like 5-minute temperature drops that were extraordinary with that one. That was wild. But yeah, I will say, all right, so circling back really quick, this is where, human forecasters are imperative. It's, this nowcasting period of time, the app on your iPhone just goes to show you cannot replace a human looking at the weather maps, looking at observations, and talking about how this shallow cold air is plummeting south faster than any other model could really capture.
Don't you like it though, in a way? I mean, when Mother Nature and real weather actually screws with the apps. That's if that.
100%. Yeah, me too. I agree.
Do you recall how well the people did? How well the forecasts were for this front range thing?
I think they did pretty well. I mean, I followed some of my friends that are forecasters in Cheyenne, and they sort of knew what was happening. I mean, you could, if it's 20 miles up the road, and I mean, I remember it coming through there, and I said, well, I wonder if it'll continue to. And boy, it wasn't long, and it was through Boulder and down to Denver. And I mean, it was the cloud features associated were just bizarre, if I remember correctly. Amazing pictures.
Oh, it's true.
Sam, you mentioned La Nina a few minutes ago. One of Bill's notes is that you've done some research on weather events during El Nino. Can you talk us through that a little bit?
Yeah, I guess so. Honestly, one of my favorite papers, one of my favorite studies I did, that I think has it got like one citation. Nobody read it, but I don't know. I really enjoyed the work. But yeah, it was looking at so 2015, 2016. It was a wild ride because there's so many different components going on there. It was strong El Nino winter, right? But a little bit of a different situation because the entire Pacific was boiling. So you didn't have the normal gradient between the equatorial SSTs in the Pacific and the rest of the ocean basin. And so the result was that rather than having this really strong, tight Hadley circulation where you have, all this convection over the tropical Pacific, and then it immediately overturns with subsidence in the central or subtropical Pacific. Everything was broadened a little bit, and so the jet stream has shifted a little bit farther north. As a result, it's still strong, but it's shifted north, and so we're getting more influence from mid-latitude disturbances that enter the waveguide. And the waveguide is really, when people say the waveguide, it's really just it's the jet stream. So anything that can perturb the jet stream, anything that can add waviness to it, that's what we're talking about here. And so in that winter, so the jet is shifted a little bit further north. We have West Pacific disturbances that add perturbations to the jet. And another impact of this was that the expected heavy rainfall that you would get in a strong El Nino in Southern California did not happen. Everything was shifting north. So Southern California, bone dry, but Northern California was inundated still from that winter. And it was, I don't know, it's a very interesting winter anyway. So those waves, right, that enter the jet stream, they don't just propagate horizontally, they actually propagate vertically as well. They can enter, they go upward through the troposphere and can enter the stratosphere. Some of the longer waves particularly. And so that can disturb the stratosphere. And, this also gets a little bit into the stratospheric warmings, the polar vortex, and all this, is connected. But one of the crazy things during this winter was also the QBO, the quasi-biennial oscillation. And so that is what I love the QBO because it is the most, or until that winter, the most predictable oscillation on this time scale in the atmosphere. It, is on a 27, 28 month cycle, and it's just an oscillation in the zonal wind at 30 millibars or in the upper stratosphere between west and east and over the equator. And so it's a super reliable oscillation. And so, it's used all the time in seasonal forecasting. And you can generally always expect what phase it's going to be in. Except this winter in particular, 2015, 2016, there was a huge disturbance in that oscillation. Rather than its normal progression, west-east, west-east, there was a quick break, a quick switch in the zonal wind direction that was unexpected. And I think, we were able to show in the paper, and there were some other subsequent papers on this, that it was influenced by these upwardly propagating waves, these anomalous upward propagating waves from the troposphere. Anyway, so there's a lot of, I like this winter because there's a lot of impact-based stuff And then there was also a lot of cool science stuff that was happening that really didn't necessarily matter that much to most people. But everything was connected. You could connect all of this wild stuff together in this 6-month period. And I don't know if I explained that very well. I don't know if anyone is gonna go jump at a chance to read that paper, but it was a fun one anyway.
That's fantastic. Do you Bill had left another note. His notes are very thorough, thankfully. Planalytics is that a former job? Yeah. That's another company I'm not super familiar with. What did you do there, and what do they do?
Yeah, this is where I went into industry right after my master's degree. And this is the little break that I had between master's and PhD. And so I went into this position specifically with the aim of working in subseasonal and seasonal space. And so they, very similar to a lot of other these same type of companies in the industry. They've forecast for agriculture and retail, among other things. And so I was working, again, in the subseasonal research space and kind of working on developing what we could for a long-range forecast system.
And that's carried over into what you're doing a little bit in research interest?
Yeah, definitely research interest. So my focus at DTN has been on hurricanes, has been on tropical cyclones, while also working alongside the great engineers on the forecast team with the engine. We have our own long range forecasting team, and it's a brilliant team. I actually love talking with these guys. We had a meeting a couple days ago where we're trying to integrate more. We have our forecast engine that goes out about 2 weeks, and then we have our long range forecast system. And again, they're using teleconnections. They're using all these techniques that really, it's something that is, tried and true. And then we continue to just evolve and get a little bit better and better with working with these teleconnections. But we want to try to bridge that gap between our forecast engine and our long range forecast. And so that particular initiative, I don't know, it's pretty exciting to me. I love working with, these two spaces.
Sam, I'm going to go back to something you were talking about because we got off of it, and I want to come back to it again with your work in looking at longer range stuff. Mm-hmm. Am I in left field somewhere? It just seems like with the oscillation, Southern oscillation, and the other, and North Atlantic oscillation, pressure oscillations, all kind of oscillations, that it seems like, and especially with Southern oscillation, that it seems like people, okay, we're in Texas, we're in La Nina, there's going to be a drought. Mm-hmm. El Nino, we're going to end up seeing a wet winter. We get into floods in parts of Texas. And I guess what kind of triggers me, we were laughing at something Jen put in the chat there for a couple of minutes ago. But what triggers me in a way is I think we're too hung up on there being like 1 or 2 or 3 solutions with these oscillations, where it's only millions of different solutions with the oscillations, and it's how the oscillations basically play with each other in a sense.
Absolutely.
And I don't know if the public understands that, because I think in a way some media says, okay, we're in La Nina, this is what it means. The one thing I've learned a long time ago is Southern oscillation in an El Nino phase could mean a bunch of different stuff depending on where you are geographically. Right. And also, by the way, if you're in the same spot, it could mean the same thing. So I wonder if you get the same feeling as well. I think we're too simplistic with that sometimes.
Oh, I couldn't agree more. Honestly, this gets back to the research I'd done in 2015-16, that El Nino did not correspond to the expected results in California, for example. We do get hung up very easily on the canonical relationships between these indices, these oscillations, and what we would expect from sensible weather. And like you said, the interaction between the indices is one way that we can dive in a little bit deeper. I think, indices are yeah, there's pros and cons. It definitely, you have to be careful not to get sucked into, latched onto one, talking about just this canonical relationship. But it does help with communication to some extent, because we can, look at this one name, we can look at this one thing and say, we immediately know what this corresponds to. And if we are smart enough about it, we can talk about the interaction, like you said. We can talk about the interaction of these indices. The biggest challenge is, one popular method for subseasonal and seasonal forecasting is analogs, right? It's super popular. You look at past weather events and past weather that corresponded with, okay, these 10 El Nino years. And so there's a lot of value in that for sure, except one of the issues is, all right, so that's just El Nino. Let's throw in NAO, let's throw in QBO. All of a sudden our sample size gets so small because, okay, well, we only have this one other year in history that, El Nino, QBO, and, whatever, all of it was in the same phase. And so all of a sudden our sample size is super small. This is where climate models, not necessarily for predictive purposes per se, but rather just producing a data set for us to look at is so useful. So beyond just using models for looking ahead in the future, we can create, a century, 2 centuries or more worth of synthetic data. And we can use that extra data as a way to procure some sort of analogs from. And so all of a sudden we have a little bit of a bigger sample size. So that's one thing that climate models are really helpful for beyond just future forecasts.
Wow.
So I got to go in a whole different direction real quick, James. I'm sorry. The whole different direction. We're going to go 180 degrees out of phase here. Okay.
Okay.
So we've been talking about, long-term, long-range outlooks, which is great. But here's my problem. And maybe it's just because it's this time of the year, but it's my problem. It's a short-term problem. And you're a PhD guy, Sam. You're the smartest guy on the show here. And by the way, I do have to ask.
That's just a label. That doesn't mean anything. I don't know.
Oh yeah, it does with this group. Yes.
Yeah, that's right. Yeah. So is that your real hair?
This? Yeah.
Yes.
It's gone through lots
Wow.
of different lives. Yeah. If anyone. If you can dig up a picture from high school, college, it would look a lot different, a little bit bigger.
Wow,
not
that's outstanding. I'm just saying that and most people listen to this show, but if you listen, you just go to the YouTube version and just you'll see what that might be. Yeah. What we need to do every year is have a top 10 hair group. Yeah. Rank our guests in the top 10 by hair, and you're clearly, Sam, in the top 10. So
don't worry about it.
I really appreciate that. Wow.
He asked the same thing about this, and I tell him I paint this thing like a deck once a month. Okay, so
yeah, show time. Right now, it's paint this thing like
colder heat that's really helping.
So I didn't mean to go down that rat hole.
Sorry.
So here's my So here's my problem down here at this latitude: June, July, August, same thing every day, 3 months, wall to wall. We know at 7 o'clock in the morning we'll have random air mass convection in the afternoon. We know that the chance of there being a thunderstorm within 60 miles of where I sit every day is literally 90 to 95%. So here's the problem. We don't know where they're going to form. We don't know when they're going to form. Therefore, the end user, the people that we serve, and this is what it's all about. We have to focus on the people we serve. This is the forecast they hear. Partly sunny with scattered afternoon and evening showers and thunderstorms, the high 92. So they've got a ball game. They've got a ball game at 3 o'clock in the afternoon at the ballpark, and they want to know, is it going to rain at the game? Is it going to be a rain out? It's 7 o'clock in the morning. And the truth is we have no idea. And yes, I understand we might have an idea of where convection might be a little more likely to develop, but other than that, we don't know. So is there any hope Sam, in dealing with air mass convection on hot summer days in the southern U.S. in the next 20, 30, 40 years? Can we ever tell people it's 7 o'clock in the morning when and where it's going to rain at 3 in the afternoon?
But the her is always so perfect, though, James.
Oh, please! And as good as that model is during the cool season, it's worthless.
Yeah,
it's. I don't show it on television. The consultants. Oh, you need to show future radar view, future Doppler scan 10,000 radar view. No, it's garbage. It's wrong. So what do we do? Any hope?
I mean, I think as far as computational resources go, at least, we that is skyrocketing, right? We have exponential increase in compute power. So we can run these super high resolution models. That's not to say that they're accurate, though, right? It's a tough one.
It seems to me, Sam, it seems to me it's the lack of real-time upper air data. To me, that's a big problem. Here we are launching balloons twice a day, like they did in 1955, and it's 2024 here.
Believe me,
what can we do to get
upper air data? Yeah.
How do we do that? How do we improve the upper air data into these convection allowing models?
I see this. Yeah. No, we got to get the money. We've already been scaling back on upper air data. I think, there's been a number of weather service offices, right, that can't launch as often as they do, or you have stopped. I'm not even sure, but we've run into issues, and it's sad, because we would absolutely benefit so much from increased frequency of soundings, density of soundings. Absolutely. Yeah.
And is there a better way? Do we need to move past the balloon launches? Is there a next gen way of measuring the upper air in real time?
Ooh, yeah. With the latest that we have in satellite technology, it's definitely helpful. The thing is, even with the satellites, they need to be calibrated against something, and that's where we still need the soundings. So all this satellite data is fantastic, for sure, but it needs to be calibrated against actual in situ observations. I will say, we probably need to get better at actually assimilating this data, like satellite data, because we have so much to work with. And this is not my area of expertise, but there are some incredibly smart people working in data assimilation, and looking at specific events and specific ways of incorporating even just like a single observation and how that can help improve a forecast. And so I think maybe we will eventually evolve also into more targeted observations, which would be nice, knowing when and where to place an observation that could potentially improve our forecast downstream or something, in the next day, 3 days, 6 days. That still doesn't answer your question about the afternoon convection, though. That's a tough one. No, that's a tough one.
It is. It's tough. It's at some point, one generation is going to get it. It will happen, but it's sure not going to happen on mine. We have given up.
Yeah.
Sam, I hear a common thread, and we've talked about it on the show a lot. Short-term models, they're not perfect. But, we seem to want more data to feed short-term models, these really high-resolution things. What's the key to feeding longer range forecasting? Obviously, the data usefulness runs out in those as you introduce error. So what's the key to make those
exactly
better?
I still say the key to making those better are increased sample size of ensembles. I think we need to fully fill out the range of possible scenarios, and then we can build out our probabilistic forecast better. Unfortunately, that really is where we are with subseasonal and long range forecasts. Again, I shouldn't say unfortunately. That's the way it is. Probabilistic is the way to go, especially once you get long range. And so we really just need to improve, I think, our sample size of our ensembles, and that will help immensely. Also improve how we perturb those models, how we perturb the physics, or as we start to dive into the AI world, how we generate the ensembles from ForecastNet, from GraphCast, for example. But I will say, yeah, for short term, I want to circle back to her for a second, because it's so true. There is so situations where it's just very disappointing, one might say. But then there's these incredible days, right, where like it gets the one supercell that
Yep.
at the exact point that's going to be at the exact time, and that's the type of stuff that just it still amazes me.
Yeah.
I think I talked to a lot of friends about this where you know, we can go back and forth between being disappointed by numerical weather prediction and thinking, wow, this is terrible, this is a trash forecast. And then you have these events, and it's just incredible what it can do or what we've done, just by putting the equations in there, getting the observations, and then boom, it's amazing.
And even down here, guys, in Texas this week, so we've been in this weakness that James and I were talking about. And earlier in the week, the HRR was behaving pretty well. And the next day it cuts you off at the knees. Like that, saying, "Oh, you thought that was good? Watch this while it just completely screw you over." And it really is interesting to be frustrated.
I definitely talk about this more from like a scientific perspective, because from a reliability perspective, from a operational, reliable forecast perspective, it's tough because because of that exact scenario, it cuts you off at the knees and like, oh, well, I can't just, like, James is saying, you can't just use the forecast radar every single time and say that this is gospel.
Yep.
How do we go in short-term forecasting from the HRR, what we're using now, to some of the stuff that Lee Orff has done on some of these supercomputers, where you've got these really super small resolution, just incredible resolution runs on a supercomputer that just is one of the best around? How do we get from that to what Lee's doing in a practical way?
I don't know if this is the right answer or this is what people are going to hear, but I don't think we need to an extent. Like, okay. I don't know. I think Lee Orff's research is, it's incredible, right? And so for one thing, the visualizations are beautiful. Let's let's stop and appreciate that before we even talk about anything else. The visuals are incredible. The actual research is great too. We need to improve our understanding of tornado genesis and what is that process between having the mesocyclone actually have a tornado on the ground. But yeah, I don't know. I think kind of I'm more in the camp of let's focus on actually getting the track of the meso down first. Let's get let's get the storm initialization down first. And I think that's where we're really going to benefit in terms of advanced warning. Yes, there's still going to be a mystery there in terms of, okay, is this beautiful looking supercell, is it actually going to put a tornado down, or is it, or is it we're just going to be looking at the wall cloud the entire time? It's still going to have impacts, hail, winds, everything there, and we'll put out the tornado warning. But things like warn on forecast, I mean, these are the initiatives that I think we should really care about, where we can talk about the path of a supercell, up to an hour, in advance or something like that, and have an accurate look at the track of the meso. Yes, there's still a mystery as far as whether it produces a tornado or not, but I don't know. I think that's where the practicality is. Personally, I don't know. That's going to offend somebody, I'm sure, but.
That's what we do on this show. We offend people, so it's okay.
Okay.
We do it gently,
no
though.
problem.
We do it gently.
Yes.
And if you don't mind me going maybe not 180 degrees, but one thing I was neglectful and did not ask at the beginning, what got you interested in weather? Because nobody plows through a PhD that's not super interested in weather. You got it in the blood. How did you do?
I honestly don't know. I know a lot of people have a particular event, particular storm that got them hooked. I've been obsessed with weather since I was 4 or 5 years old. I think it could have been my dad, cursing at the Weather Channel when it was going to rain over the weekend, and just growing up with that. But yeah, no, I've been obsessed with weather for as long as I can remember. And it was actually problematic because, through high school, I knew I was going to go into meteorology, major in meteorology in college. I think it was entering college. And so, like, you're right, all of my friends, everybody else had to, make a choice, make a decision about what they're majoring in. And I didn't, I didn't have this decision to make. And then in undergrad, I think maybe moving to like senior year and talk about grad school and all, you realize that there's a decision now. There's so many different pathways you can take within meteorology, right? And I hadn't faced that yet in my life. Everyone else had already faced making the decision about their major. And it was weird to me to realize, oh, wait, there's so many things you can do in meteorology. And yeah, I think I don't know, went through a little crisis there. Like, I got to pick something. But I think academia was, I wanted to continue with academia because I loved research. I loved just doing these deeper dives. And
what's your advice, Sam? So let's say some kid wants to do what you're doing. They're 16, 17. They're in high school. They want to get to your level. What's some advice for them?
Oh, I mean, I think just first lean into your passion. For better or worse, I found online forums, and I loved talking to other weather nerds online. It was great. Twitter can be good or bad, it can go either way, but like it fosters this discussion between these equally passionate people about weather. And I think that's fantastic. I wouldn't say it's not cynical, but like I would say one huge thing is you get familiar with coding. I mean, programming takes you so far. Dive into Python. Honestly, the best weekend you can spend is just like locked up with a laptop, learning how to code in Python, and that you will look back and realize that made your career when that one weekend when you learned how to code. So yeah, even in high school, dive into coding. All the rest, obviously, physics, math, it's important just because those are the classes in college, and I love that stuff. It's less applicable today in a lot of jobs, unfortunately, just because I loved it. I realized I'm not using it as much. But yeah, I think coding and staying networked with the rest of the weather world.
Did you ever have a
I think we should all lock ourselves up, James ate a lot. We should lock ourselves up for a weekend and let's do some Python. What do you say?
That's right.
Let's do it during football season. That'd be awesome.
There you go.
We'll do it on Iron Bowl that weekend.
Yeah, sure.
Time to cut the Tulsa line.
Grab a beverage of choice, of course. That's not for the high schoolers, but for us, that's
big beverage.
Yeah,
a big beverage. Yes.
Which class in your undergrad? I mean, we all had one or two that were probably a nightmare. What were some of the hardest classes that you took, and how did you get through them?
Nightmare class. Good question. I think in undergrad I was still so much of a nerd that I was really just diving into every class. I enjoyed it all. I do think I did take. Let's see, I took an NWP class where we had to code in Fortran, and that was definitely a challenge. That was a tough one, and definitely took some time. I took I think a radiation class or something of that sort. I was never good at radiation. I didn't really follow. Yeah, a lot, like, I don't know. I couldn't wrap my head around a lot of that, and so I took a few grad classes too that got into radiation. And oh gosh, I mean, there's some brilliant people that I just cannot follow on what they're talking about.
So I got a question. So while we're talking long range, let's just get real here. I mean, here we are in July. So Sam, tell us about the rest of the hurricane season. Go.
Oh boy. Yeah, this is a wild start, and and not for the all right. So everyone's gonna think I'm talking about Beryl. Honestly, I'm thinking also about the Saharan air layer kind of just shutting things down over the last few weeks.
Yep.
I mean, it's still July. It's July. This is what happens. 2005. Sure, we had Emily and Dennis. But yeah, things were quiet after that for a stretch too. Yeah, so we have to remember this is still super early in the season. That being said, right, so the ocean is still, record levels across the Caribbean, Gulf, across in, a lot of the MDR. I think we're going to see a lot of barrels, unfortunately. Really, as long as everything else allows for it, right? We have all these other factors. We have the Saharan air layer. We have stability to consider, and then even just what you end up getting through the mid latitudes. You can get these PV filaments that dive south, introducing more shear. So there's all these other factors, right? This gets into the probability space, but I think with the pattern that's setting up with La Nina, we have generally reduced shear across the Atlantic. We have the hot water in place. I don't know how many storms. I think this is actually the bigger question. How many storms happen? It could be 18, it could be 32. But it doesn't matter. Right? Either way, that's an active season. It's what those storms do though. And with all of that fuel right now, the ceiling is so high for all of these. And that's what Beryl showed. We can get a storm over there this time of year. It's not that crazy. It's a little anomalous, but it's not that crazy. It's what Beryl did over there that's amazing. The rapid intensification, the bolt up to Cat 5. I remember I was talking to somebody when it hit low end Cat 4, I think, and I was like, there's no way. I mean, and I was basing this purely on the time of year. I'm not gonna lie. I was not looking at anything else. I was like, it's early July. We're not gonna get a Cat 5, we're not gonna get a record Cat 5. But yeah, the fuel speaks for itself, I think, unfortunately, as far as what this season could hold.
We're tormenting
so if you could
with a
pick
lot of
one
questions. Oh, go ahead.
No, go ahead, James.
Yeah, I was going to say, we're bugging you with a lot of tropical questions.
That's good.
Why have we had so many rapid intensification hurricanes in the last few seasons?
Yeah, I mean, even last year when we had more shear, that we had to deal with, and that's what kind of suppressed the number of storms. But when there's a window, the storms have been using that window. And so like Lee, that was, incredible. I think some people kind of forget about Lee because, it was offshore. But that was an incredible period of rapid intensification. And I haven't answered the question quite yet, but I do want to mention the ability to forecast these episodes of rapid intensification is improving substantially, or maybe the willingness to forecast them, because the National Hurricane Center has over the last couple of years progressively, pushed the boundaries of what they're willing to forecast. I think 10 years ago, you would not see many objective rapid intensification forecasts. And now we're seeing, 40, 50 knots, in 24 hours that they're objectively saying it is that they're expecting. And that's amazing because not only are they doing it, but it's verifying, these are great forecasts. And it does, it connects back to the ceiling idea, the fact that with how hot the ocean is, the ceiling is so much higher for these storms to take off. And we're not only getting rapid intensification from, tropical storm to Cat 3, but we're getting rapid intensification even while it's already a Cat 4, adding 30 more knots. And that's what's really amazing to me is that, at already a very high intensity, it can still take off more from there. And I think that's what we're also seeing a little bit more of in the last few years. And it just gets back to fuel.
So, and here's one question I have, and we have to take a break here in just a second.
Sure.
But obviously, we're down here in tornado country. Yeah. And there's a lot of pressure from people, different folks, emergency management folks, the public, industrial users, first responders, hospitals. Mm-hmm. Tell me what the tornado season is going to be like. And understand where we are. It basically runs from November through May. November through May. That's the tornado season. And so here we are in July, and we're already getting those questions. Is there any skill at looking at the frequency of tornadoes for a given part of the United States, several months in advance.
Yeah, and I mean, I think this really connects back to ENSO again, to La Nina, El Nino, and I mean, I'm going to fall into the same trap that I was just talking about, where we connect the canonical relationships of ENSO to what we'd expect with sensible weather, and it doesn't always play out as expected. But the relationship would be that the La Nina this winter would suggest that there would be more activity shifted more towards the classical tornado alley in the Central Plains, and a little bit later, versus El Nino, which really, with the subtropical jet, can lead to some of this earlier activity across the southeast. And so I think in theory, following that theory, maybe we are looking at a little bit of a nicer, tornado season for the deep south, but I would definitely not put money on it.
You heard it. You heard it on this show. I'm taking the next 8 months off, so we're not going to worry about it because Sam said it's all going to happen out there where James A is working. So good luck with that, James.
Well, I think we all need to remember what our friend and fellow weatherbrainer Rick Smith says: the Oklahoma tornado season runs January 1 through December 31st.
It's so true. Yes.
And you'll get that one right. So
that's a great
point. But every year, they'll tell me, well, April 27, 2011 was a La Nina tornado outbreak, and La Nina means this is going to be just as bad as 2011. And the INSO phase thing, it's interesting, and I'm sure there's some correlation, but like you say, Sam, it's not as tight as some people think it is. It's not that hey, predicting the future is hard. Wouldn't you agree?
Yes. I will say that there's another connection. The warmth of the SSTs over the Gulf of Mexico can also correspond to the intensity of the severe storms, and also I think potential for increased tornado activity. So that's another one to consider, how warm the Gulf is right now. Now, if we get 32 hurricanes in there to cool things off, but no, I know I'm shaking my head too on that one. Not dealing with that.
And then there's clearly, I agree, there's a correlation between SSTs in the Gulf and tornado frequency and intensity. We've seen that here too. So hopefully we'll get some of that heat transferred in the hurricane season, but we'll see. But we have to take a quick break here. Can you stay with us for a few more minutes, Sam?
Absolutely.
Okay, good. And I'll warn you, we'll warn you here shortly, we're going to do picks of the week where everybody's going to have something cool that's weather related. This can be a data source, a product, a website. So be thinking of that. And while you're thinking of that, we're going to take a break. We're going to hear from Tony Rice and Tony's astronomy report, and we'll come back and do a little quick weather roundup, picks of the week, and much more as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
You might have heard that SpaceX is grounded, specifically the Falcon 9 rocket. This comes after a liquid oxygen leak on the second stage of the launch of the Starlink 9-3 mission back on July 11th. This is especially notable because it puts an end to the years-long run of successful launches, 69 so far this year alone. The company requested last week that the FAA allow launches to continue, arguing that since the anomaly occurred in the later stages of flight, that it doesn't present a significant risk to public or private property. As of this recording, the FAA was still considering that request. So what does back to flight look like for SpaceX? And why is the FAA involved here at all? The company needs to come to some understanding of why the Merlin vacuum engine was unable to complete that second burn, stranding 20 Starlink satellites in an unrecoverable orbit. The FAA needs to be satisfied that the problem is found and fixed, especially since there's a couple of crewed missions scheduled coming up in August. So why does the FAA have oversight over a rocket company? Well, the short answer is that their mandate is to ensure the safe use of the U.S. airspace, which spacecraft are definitely flying through on their way to space. The FAA is also the agency tasked with ensuring that the United States meet its obligations under international space law. Yeah, that's a thing. And it's most easily summed up as, if you launched it, it's your responsibility. And here the U is the government of wherever the launch pad is. So, if something bad happens with a SpaceX rocket or a payload delivered to orbit by SpaceX from Florida, California, or soon Texas, it's ultimately the responsibility of the U.S. taxpayer. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
Hey, hey, hey. Time to dig into the email inbox and see if maybe something is in there this week.
All righty. So I've been going through all the email, trying to get caught up a little bit, and we're still having a small email issue. So if you do send us an email, make sure you put your name and your email address at the bottom for us. But I do have one from Tom, and this was back after our July 15th show. And thank you for a good show tonight. Something occurred to me in the discussion of messaging that I didn't hear anyone considering. Just what do people actually know about weather and meteorology? How much information about weather do students get in K through 12? And what do you wish they knew when you prepare or present a forecast, cover severe weather, or otherwise tell them about the weather? So I thought that was a pretty good set of questions there about, let's just start with, what do we really think people know about the weather? And what do they learn in school? I mean, James, you're in schools every day.
I choose to believe that my audience is fairly good at weather knowledge. I really do. So often in the media, I think we're guilty of treating our audience like they're idiots, which is ridiculous. These are brilliant people, and where we are here, obviously, it's a very high impact thing, and I think they're darn good at it. And I'm not afraid to get on television during tornado events where I'm trying to communicate life-death information and show some high-end products and services. All these dual polarization products, and do a little, let's peg the geek meter here. I have no problem with that. So I choose to think that my people are pretty good down here.
Well, you got to keep in mind too, though, James, you're very good at what you do with your audience, and I can see that. But I wonder if people, and Sam hop in on this as well, that I don't think people understand the extent of math there is in meteorology. And sometimes there's meteorology people that are going into meteorology that find out that what that math can involve. Because I mean, we're talking about at least used to be through differential equations. At least I don't think people understand that kind of background, and I guess maybe they just don't understand the fact that there's there's no promises in our business. I still get notes from people. I got an email from a friend here in Central Texas in the last week, and he said, we've had a 60% chance of rain for the last 3 days and not a drop of rain here. And I'm sitting here going, okay, let's talk about probabilities for a second. It's a point probability, has nothing to do with aerial coverage. At least what it means doesn't have anything to do with aerial coverage. That goes into the pops maybe. But I don't think people understand that, and maybe it's best they don't. But I agree too that it's a rigorous academic program. Let's put it that way.
Yeah, and there's a difference, Troy, between daily weather forecasts and understanding probabilistic weather forecasting as opposed to a tornado emergency where I've got a tornado down, and that's a whole. And I agree with you. We do have a lot of education when it comes to again, this time of the year, like you say, every day. The typical pop in summer is 30% here. Yeah. And of course, if it's pouring rain, they're going to call us an idiot because it ought to be 100%. If it doesn't rain, we're an idiot because it ought to be 0%. And again, we have to be careful. We cannot be condescending and blame the audience, the people we serve. Right. We have to turn that camera on us and be better communicators. The daily stuff can be problematic, and sometimes, especially during complex winter weather events. Yeah, we're not that. Let me rephrase that. I'm not that good at it. I do okay with the tornado stuff, but I'm not that good during weather events and winter events, and we have to be better at it.
Well, yeah, but we're talking about being in the southern U.S. And the biggest problem is P-type, essentially precipitation. What is it going to be? What's this atmosphere going to dictate? And you sit here for 3 days, and the model shows snow out here, and you finally say, okay, I guess I'll go with that. And then it's 25 degrees and it's pouring down rain. We've seen that here in Austin, outside this building. And you sit here and you go, this is really complex, you know, really, really complex. But by the way, I want to get a plug in here. Watch this, Jen. We're in the 5th of August, a week from Monday. Jen and I will be having college night here on WeatherBrains. We're going to talk about the things you need to know about, not necessarily about the differential equation, but a lot of folks going back to school, either new into programs or their senior year into programs. We're going to talk about things you need to know about college. We're going to run around the WeatherBrains around here and just kind of talk about some things you gotta know. And if you don't think I'm loaded for bear, you're wrong. So it's going to be a fun night. I'm looking forward to that, Jen. On the 5th, on Monday the 5th, college night. No guests that night. We're just gonna talk.
Yep, we're just going to have a real conversation. And yes, current grad students on the panel get to participate, James A. So yeah, I want everybody to weigh in. I think it's going to be, because we have so many high schoolers and college students that listen to the show, and I'm really excited about it.
And to Jen, we thank Nick for his email. Nick is headed off to the University of Wisconsin in the fall, and spent time with him in the last week on the Zoom call, and you spent some time with him. So that's what we're going to do on the 5th.
Yeah, that's going to be great. That'll be great. Back to our question. I do have a couple of thoughts. First of all, I never realized when I first started doing radio back in 1997, and here I am still doing it, how hard it would be to do winter weather for 70 cities around the country. That's really hard to do, and to do it in 20 to 25 seconds. That's all we're allowed to do these days. How do you say that when you're trying to tell people, how to stay safe? But that's neither here nor there right now. But a couple of things I was thinking about, what we want people to know. I still get texts when we have a tornado warning here. The sirens are going off, or I got a tornado warning. Should I go to the basement? Yes, I'm in the basement. The meteorologist is in the basement. You can please go to the basement.
Yep.
And then the other thing, I wish there was a better grasp of geography. Where are you in your county? Having RadarScope is great, but do you know what county the cell is in, and where is it coming? Which direction is it coming from? And all those type of things. I think that there is a struggle with geography.
Yeah.
So.
And this country, the United States, is geographically ignorant. I hate to say it.
And what's happened? It's phones. And people have turned by turn directions, and they have lost their map skills. They have lost it. And again, we can't blame them. They're just using technology. And again, I mentioned this earlier, I think in the pre-show, the Weather Service in Birmingham, they had me throw some graphics up on Facebook this evening, older graphics, and have people that don't understand it, kind of raise your hand and let's learn from you. And we all need to learn from them in ways we can be better. But you're right. There is a total geography literacy problem in this country. There's no doubt about that.
What about our grad students here? We have James in Tulsa. We have Sam. What's your feeling?
James, you want to take it? I feel like you guys have already covered a lot of great points, honestly. I think I was going to mention probability, and I was going to mention winter weather. Circling back really quick, by the way, this is where upper air observations are super important, and we could use a much denser network of upper air observations for winter weather. I think the big thing I always like to do is try to communicate, okay, this is dependent on half a degree at a mile above our heads, which is wild. And I think that cannot be emphasized enough to the general public, what the difference between a foot of snow and an inch of rain, or inch of ice can be. And then the probability problem that is just so hard. And honestly, even there's even meteorologists that I think struggle with that.
Well, with that, I'm going to throw it back to Okie, James, because I think we ought to replace that 40% chance, or how about 50% chance of rain, with what James in Tulsa had just put in the chat a few minutes ago. Instead of using that 50%, let's get rid of that. This is much more understandable to you, James.
Yeah, Troy wants to discuss rain probabilities by how many standard deviations.
There we go. See, everybody understands.
I like that. Yeah.
I think every consultant's head just exploded.
Yeah, yeah.
But
So
you know,
what's your feeling all this, James? Because you hadn't had a chance to say much.
you know, I think we're still, the science has advanced so far,
Yeah.
which is remarkable, just in 10 years, 20 years especially. But there's still a little bit of a communication gap and a perception gap. The best warning is only so great if it's not communicated to people that need to make a protective action effectively based on that warning. So there's still a big gap there. I think there's a gap in how we try to do severe weather too. Severe thunderstorm warnings, you know, if it's 60-mile-per-hour winds and quarter-sized hail, that's no big deal to me inside the studio here or at home, but it's a really big deal if you're on a boat or out in the open. And there's a communication gap here that I think, thankfully, Tim and the social science people are really have come so far in getting these Venn diagrams to overlap and getting just this mix, this multidisciplinary mix to make these warnings effective.
Let's go back to what James has told us from Central Alabama before. And like you say, James, it's a social thing. How do you tell someone to seek shelter and they're in a mobile home in southeastern Alabama, and Alabama is not exclusive to this, but they're in a mobile home and the breadwinner has the car and they're at work? You have no mode of transportation to get to a tornado shelter. So this is coming down to the social sciences that Kim sits here and she talks about very often. We've got to look at this. I mean, the warnings in a lot of cases are really good meteorologically these days. I'm just not sure they're good socially, and the communication side is good.
Yeah. This also goes back to tropical forecast too. I mean, as much as we talk about for the last 5-10 years how, you know, don't just look at the center line and, you know, or the center track, and don't just focus on the strength of the winds. Those are still the two pieces of information that we feed the public. Like, so we're not, it's tough because we're not really doing them a service either. It's a little bit of a challenge. We're fighting ourselves where, you know, hurricanes are best categorized by a latitude and longitude center and their maximum sustained wind. And yet those two pieces of information are like the least important thing to somebody, you know, that's, I don't know, 30 miles away or something. But yeah, it's so important that we need to, you know, communicate storm surge, freshwater flooding from rainfall, tornadoes. I mean, gosh, with Beryl, you know, and so these are the other impacts, and then the spatial distribution of those impacts. It's really, it's a challenge because we are sort of fighting ourselves a little bit here.
And that's why I always say we need to hang out in Dollar Generals and Walmarts, because we're all a bunch of pinheads. We sit around these, you know, nice little tables, these conference mahogany tables, and we decide what's best for us. It doesn't matter. We have to understand the audience we serve. And again, the easiest thing to do is to be critical of the people we serve. And that ain't it. We need to be critical of us. And like Troy says, I've got a family in a mobile home. They have no transportation. Well, it's really easy for some blow-dried boob on TV to go and say, leave mobile homes now. But what if you don't have transportation? You know, we need to do more for them. And it is a social science problem, and we have to take that interdisciplinary approach with social and physical science to be better. And that's why we'd like to have Kim on this show, because she's so much better at that than we are. But anyway, Jen, thank you for that email. That was a good discussion.
Yeah.
Why don't you plug our email address one more time?
Yeah, thank you, Tom, for that. It's email@weatherbrains.com. Write, you know, your show suggestions, your questions. Please, at the bottom, put your name and then your email address again, because we're having a small little snafu, and maybe you will become the email of the week.
All right. So let's kind of roll into our picks of the week. I think we've already kind of talked about what's going on nationally in terms of weather in the tropics and everything else. So let's go into picks of the week. For those that are new here, every week we have the ending segment. This is where everybody on the show, including our guests, they come up with something that's really cool. This can be a data set. It could be a some software, could be weather instruments, could be just a website, a historical event, anything like that. And we put all the links on our website, weatherbrains.com. That's where you'll find the show notes from these episodes. So let's begin, Jen, with you. What is your pick of the week?
And a shocker, it's a tornado history event of July 25th,
Hey.
2005. The citizens of Sandpoint, Alaska saw a rare tornado touchdown a nearby uninhabited island. Sandpoint is part of the set of islands at the beginning of the Aleutian chain. It was an F0. Very rare, very few tornadoes on record in that area. And this is from the Weather History Twitter account, X account, whatever. The great account, but that's a great tweet for today from tornadoes in Alaska.
Awesome. It's always going to be the tweeter to me, always. So let's go to James Adelot. He's getting ready for Action News tonight at 9.
News.
But Eyewitness, live, local, late breaking, the Weather Authority. James, what's on your mind? What you got?
Yeah, if it's news to you, it might be news to us too.
Yeah, that's a good one too. Yeah.
Our my photo of the week was a inside the cockpit view from an aircraft from the 146th Airlift Wing of the California Air National Guard, busy doing aerial retardant and water drops on the Longfire in California. And you can get a feel watching that video just how ridiculously turbulent it is to fly that low around mountains and fires. And my hat's off, those people are heroes.
Mm-hmm.
Wow. All right. Outstanding. All right. So let's see, Troy, how's that chili sitting with you?
I don't think people knew about that till now. I think that was pre-show, but I'm okay. Doing okay.
Oh,
Hey,
that's true. That wasn't a pre-show. I was
That
asking
wasn't
people what they
pre-show,
had for
yeah.
dinner, and
probably
the
shocking people.
beans
There's
are
your
the
new
magical
show title now. How that chili treat me.
beans are the magical fruit. We all know
They
that.
are. They are.
In Texas,
Sorry, I was left out,
No.
on this discussion.
No.
you didn't dare put beans in Texas chili, did you?
What's that? Of
Oh,
course
You
I
didn't,
I
you
don't.
didn't dare put beans in chili, did you?
Yeah, beans and chili. Absolutely. Chili
Uh,
needs beans.
You're going to get run out of that state.
I don't care. Come run me out. Hey, the National Weather Service office up in Reno. In the last couple of hours, of course, we're recording on Thursday night on the 25th day of July. But in the last hour or so, y'all see this, the video from up there. I believe this is up at the WFO, but I may be wrong. It's another, this is a different camera. From around Fairview Peak, shows a wet microburst moving toward US Highway 50 down there. And this is very impressive. If you hadn't seen it, NWS Reno, and that is my pick of the week.
Outstanding. And my pick goes to a really interesting story involving the 1930s and the 1940s in military.com, how Jesse Owens' Olympic teammate kept the Tuskegee Airmen safe during World War II. It's a fascinating read about weather and history. I was not aware of this. So again, if you like history and you're interested in that era, it's a really interesting read, and some meteorology is involved here. So again, that'll be my pick of the week. All right, so Sam, we've stalled long enough. We know you
I
got
appreciate
something
it.
really good.
Thanks for the extra time. I'm not sure where to drop this. Is there where should I drop a link somewhere or share a
You
screen?
can put it in the chat. Yeah.
Oh, sure. Put it in
Yeah,
chat. Well,
you
first,
can put in the
so-
chat.
Okay. I wanted to plug, first of all, a Python package for those, those budding Python learners called TropICal that my friend Tomer Berg and I had developed several years ago. Honestly, it's something that I'm probably most proud of in my life. Python package for visualizing everything related to hurricanes, past hurricanes, seasons, model runs, recon data, everything. So please do a deep dive and ask me any questions because I love it for visualization purposes. It's fantastic. Also, because I wasn't entirely confident on how I was doing the pick of the week, I do have something physical to share too. This is from my very good friend, Austin Coleman, who made a painting of Hurricane Sam satellite picture, specifically from September 30th, 2021 at 21Z, 938 millibars and 125 knot sustained winds. So
That's cool.
this was a gift, but I'm
really
sure
cool.
she can make them for $1,000 a piece or something, whatever their going rate is.
That's awesome.
But those are my picks.
That's beyond cool. And so for those asking, what kind of product do you have up there in that hair before we leave?
Sam will
telling you,
never
this
come
is just-
back. He will never come
this
back.
is
No,
just
he
pure
will
Colorado heat.
never come back on this show.
This is just pure
what was it,
Colorado
Sam?
heat. That's pure Colorado heat that's fluffing it up right now. You know?
All right.
Thermal.
Yeah.
Colorado
Exactly, it's a
heat,
thermal.
fluffing it up. Boy, that's a
Yeah.
good. We've had so many good show titles on this. So Sam, if somebody wants to get in touch with you, or are you like on the socials at all, the X or to tell people how they can get in touch with you?
Yeah, I'm on the X. So my handle on Twitter /X is SP Lillo. And then otherwise, the same for my email account. If anyone wants to reach out an email, happy to answer any questions.
Outstanding. So again, thanks for coming on the show, and thanks to all of you for listening. And again, if you are new here, we're typically live Monday nights at 8 o'clock Eastern, 7 o'clock Central. Again, this is a little anomalous here because we're doing the show on a Thursday. It's a Thursday night special. But we will be back on the regular Monday schedule on Monday, the 5th of August, and we'll be on Monday nights for the rest of the year. But we know that most people listen. Sure, you can watch us live, youtube.com/weatherbrains, but most people listen to the audio podcast. However you watch or listen, thank you. And if you want to get in touch with us, our email address, it is email@weatherbrains.com. And again, please put your name and your email address at the bottom of the email while we're having a little email issue here. But we read some on the air, and for some we just answered directly, but we'd love to hear from you. So on behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a great week, and God bless. Ooh, that was a good show. Sam, thanks. That was good.
Sam, thank you.
Sam.
Thank you so much for having me. This is so
Great.
much fun.
Yeah, awesome.
It was a great show. Thanks so much.